So in order to do part C, the question we need to ask is, how does this process change if we have a denominator that is negative? The answer is, the first step is going to be exactly the same. It's later in the problem that you have to think about what that negative does for us. So we've seen previously that if we have a two-termed polynomial in the numerator, we can break it up into two smaller fractions. So let's play that same game. I'm going to have the first term of my numerator, 6x, divided by my common denominator of negative 2. Then we're going to have the minus 9 divided by that common denominator of negative 2. So now that I have that, once again, that's exactly the same as what we talked about earlier. So now the question is, how does this change? Well, it just becomes a matter of thinking about what that negative does for us. So we have a positive 6 divided by a negative 2. Well, positive divided by negative is going to be a negative, and then 6 divided by 2, we can cancel a 2 out of both of those, and I end up getting 3. So we're going to get negative 3, and then of course the x moves forward as well. Then as I look at my next fraction, we have a negative 9 divided by a negative 2. Negative 9 divided by negative 2, negative divided by negative is going to be a positive, and 9 divided by 2, I don't have a factor that is common there, more exciting than 1. So I can't do any cancellation, so it's simply going to be 9 divided by 2. And there's our final answer. Negative 3x plus 9 halves. So now let's go ahead and check out part D. There are two things that I want you to notice about part D. First off then, I want you to notice that our numerator doesn't always have to have two terms. We can have as many terms as we want in that numerator. So in this case, I happen to have 4 terms. So the first question then you should be asking is, if we have 4 terms in that numerator, how is that going to affect the process? Well, instead of having 2 smaller fractions, like we did when we had 2 terms in the numerator, we're going to have 4 smaller fractions when we break this up. If I had 7 terms, I would have 7 smaller fractions. So the number of terms that you have in your numerator will always tell you the number of smaller fractions that you need. The second thing that I want you to see about this problem is that our denominator doesn't always have to be simply a number. We can have x's and powers of x's in that denominator as well, as long as that is simply a monomial. So yeah, our denominator is a monomial. And because that denominator is a monomial, I can use the same technique that we've been talking about. So let's go ahead and talk about all of those pieces together. So I know I'm going to have 4 smaller fractions. The first term in my numerator, negative 12x to the 4th, is going to be divided by my common denominator of negative 3x. The second term in my numerator, positive 6x squared, is going to be divided by my common denominator of negative 3x. My third term in my numerator, negative 15x, is going to be divided by the common denominator of negative 3x. And then finally, my last term in my numerator, a positive 4, is going to be divided by my common denominator of negative 3x. So now what I have to do then is look at each one of these and think about how to reduce these. Now, at this point then, I have to think about things in terms of divisions involving integers, but I also have to think about my rules of exponents from a couple of sections ago. So, okay, let's play both of those games then. So first off, I have negative 12 divided by negative 3. Negative divided by negative is a positive. 12 divided by 3 is going to give me 4. And then, in terms of the x's, I have x to the 4th divided by x. Now, remember once again, this x is really x to the 1st. And then we have to see that this is an example of a quotient rule. So x to a power divided by x to a power, we subtract the exponents. So 4 minus 1 is 3, so that means that we're going to have x to the 3rd there. Well, let's check out the next one then. We have a positive 6 divided by a negative 3. Positive divided by negative is going to be a negative. 6 divided by 3 is going to be 2. X squared divided by x to the 1st. 2 minus 1 is 1, so this is going to be x to the 1st. And again, the tradition is not to write that power of 1. Let's check out the next one. Negative 15 divided by negative 3. Negative divided by negative is going to be a positive. 15 divided by 3 is going to be 5. Now in this case, the x's are simply going to cancel each other out. So I don't have any x's left on that one. And then, as I look at my last one, positive 4 divided by negative 3. Well, positive divided by negative is going to be a negative. And then on this one, the 4 and the 3, I can't really do anything in terms of cancellation. So I'm going to have a 4 in the numerator and a 3 in the denominator. Now, sometimes when people look at this problem, then they try to move that x. So you want to be really careful and make sure that your x lands in the right spot. Notice that this x is in the denominator here, so I need to make sure that my x is in my denominator in my final answer as well. So there he is in the denominator in my final answer. So anytime you're dividing by a denominator that involves an x, there's the possibility that you're going to have a fraction here, and that fraction has an x in the denominator. So always make sure that you're careful about making sure that that x doesn't somehow magically move up into the numerator. So there's our answer. 4x to the third minus 2x plus 5 minus the fraction 4 divided by 3x. So at this point then, you are ready to go ahead and do the homeworks for section 33.